Say that you are developing malware. For all the right reasons, of course. Maybe for your job as a red teamer or cyber threat emulation offensive security specialist, and you are building an implant. Like an endpoint agent that runs on a victim computer and operates as a beacon that just calls back to a command and control server or framework, like a C2. And it makes sense for you to want that beacon to be as lightweight as possible. At its core, it should really just handle communication with the C2 server. But you'll still want extra capability. You want it to do more than just that, like continue post-exploitation or persistence or exfiltration or whatever. You don't want to bloat up the beacon code, and you shouldn't really spawn or invoke some other external or child process, because you may very well get detected. You want something that has all this functionality in an extensible and modular way so that it on the fly could do anything else. You want beacon object files, or BOFs, or BOFs. BOFs are a concept first introduced back in 2021 with Cobalt Strike, one of the most infamous post-exploitation frameworks and command and control servers that are out there. Here I've got pulled up the Cobalt Strike beacon object files documentation, and I'll include a link to that and many others in the video description. But these beacon object files are a method for loading and executing native code in memory at runtime, similar to loading and executing a DLL or dynamic linked library, but letting you remain a little bit more stealthy. Beacon object files themselves are unlinked object files in the form of Microsoft's Common Object File Format, COFFs or COFFs. But let's get hands-on keyboard. So I'm inside of my Kali Linux virtual machine, and I'll use this as the offensive or attacking host, and I'll open up my terminal with Control-Alt-T as the hotkey on my keyboard, F11 to full screen, and I'll zoom in a little bit to make this text bigger and easier for you to read. Let me make a directory for us to work in. We'll just create BOFs with the mkdir command. Let me move into that directory. And now let's try to develop a structure for our example BOF. This is just a skeleton for us to try and understand, but really developing a BOF requires some C or C++ code and then compiling it into a COFF. So we'll create our example.c in a text editor. I'll use Sublime Text, and we'll start as small and simple as we can. In fact, we'll just create a void return type function called go, and it won't do anything. We're done. That's all that we need to start. Let me save this and then show you the process. We'll compile this into an object file using mingw-gcc, the GNU C compiler, and making this work on Windows. Inside of Kali Linux, if you have mingw installed, is x86_w64-mingw32-gcc. I know that's a mouthful, but you get it. And we want to be sure to use the tac-c flag, which will tell the compiler to produce only an object file, or COFF, instead of a fully linked executable. We'll specify -o so we can make sure the output is example.o as the object file, and then we'll include our example.c as the source file for it to work with. I'll hit enter, and that will compile. Now inside of this current directory, if I ls, is both our source code written in C and our .o object file. In fact, I can run the file command on that example.o, and you'll be able to see. This is a COFF object file. Now, I will also be using a Windows 11 virtual machine to act as our victim, but I do want to show you, let me just take a moment to say, hey, you can compile and build out these very same beacon object files, BOFs or COFFs, with the Visual Studio developer prompt, because then you'll have the cl.exe or command line compiler on Windows. So if I open up that command prompt, let me hop over to my temporary directory. I've created a BOFs directory here just to show you as well, and you can use cl/c and another important option /G_S and a minus or hyphen to specify we want to omit stack canaries. Stack canaries can cause issues with undefined symbols and don't really work well with BOFs or beacon object files, so we want to make sure to include that. Then we'll use /f, specify our output, and I know this is weird, we're kind of joining the words together, but let's make our .obj or object file, at least whatever Windows naming conventions, based off of our example.c that I do have in the current directory here. Let me show you that. You can see example.c present. Again, empty void go function. Let's compile this, and then it's done. But obviously, this object file, both on Windows and Linux, it does nothing. We defined this go function, which is the right convention to be able to work with a beacon object file, but we need it to do something. Even if we were to run this code with a BOF loader, which is what will be used to actually execute these with your C2 agent or implant or beacon, this still isn't going to do anything. We need to work with the beacon API. The beacon API is part of the convention for writing a BOF. And I've got the Cobalt Strike documentation up and open again. We'll link in the video description. But to use the beacon API, a set of functions exposed by the BOF loader that a BOF can utilize, we need to work with the beacon header file. Beacon.h. Let me copy the link here so we can download this in our Kali Linux VM. So I can just wget this down and we'll have the beacon.h file present. This is a header file, of course, and it should be placed in the same directory or same folder with our BOF source code. Let's open up the beacon header file and see what it can do. I like reading the comments here because there are a couple other additional resources that I think would be worthwhile for you to explore. We'll dive into the API and more of the different functions that you can call later on when we take a closer look at the documentation, but for now, let's start small. You can see a couple of the functions that are available here, like beacon data parse, stuff to work with data or format information, or even simply just display output. There are a couple other convenience functions, but ultimately, we want to be able to run Win32 API functions. We still kind of need to sanity check though, so let's make sure we've got something working and compiling and running, even if it is just a simple hello world beacon print. It's worth looking through a lot of the other functions and things that are available here, but ultimately what we will do next is just make use of that simple beacon printf call. So of course, back in our example.c source code for our beacon object file, we will want to include that beacon.h header file. Now we'll be able to call and use some of those functions like beacon printf. If we look back at the header file and definitions, you can see that these functions here take two arguments, at least at a minimum, right? You'll take the type of output as an integer and then a string or a constant character array with what you want to display. The output function types up here define that first argument that we'll supply. So if we want a simple callback output, that's what we'll use. So back in our C source code, let me paste that in as part of the parentheses, the arguments that we'll use to call this beacon printf function, and then we'll do a simple hello world. Of course, we're in C, so let's use a semicolon to make sure we close out that line. And if you wanted to look back at the beacon API, again, the documentation should cover all of this with the data parser API, different functions that you can call here, output API, it just includes a little bit more details, formatting info, and plenty more. Again, we'll include a link in the video description here if this is helpful. Now let's get back to the command line and try to compile this once again with that x86 command. Using mingw as the compiler, up to date, now we have our example.o object file as our BOF, but now we need to figure out how to run it. Remember, this is a common object file format, or the COF. And COFs on their own can't just be like executed because they're not full executable files. A BOF loader needs to be used in order to actually run a beacon object file. BOF loaders will read in the compiled BOF and execute it in memory. There are a lot of different open source COF or BOF loaders available to use, but one of the most popular ones is this project on GitHub, COF Loader. This is put together by the incredible team over at TrustedSec, and it can be used for testing without a whole Cobalt Strike agent or C2 server up and running. It's still an awesome way for us to test and develop BOFs, so let's try to download this code and work with COF Loader. This can be ran and compiled on Linux, so let me git clone this down. and I'll move into that directory for cough loader. You can see all of the source code is available here, but they include a make file. So we can very easily just run the make command, and that will build it all. So we have executables ready for us. Take a look. I might zoom out so you can see there's our cough loader for 64-bit and cough loader for 32-bit, now both present in our local directory here. Obviously, these are .exe files or Windows portable executable files, so those need to run on Windows. We can transfer these files over to our Windows virtual machine, but you need to know that these will be flagged by your antivirus. These executables will be considered malicious by Windows Defender. So I have Windows Defender completely removed from this virtual machine, and we can get them into this environment. I'll paste these here, but since we can look through the source code of the cough loader, we can make sure and verify, validate there is nothing malicious in here, but it's best to use a Windows virtual machine for testing so that we don't unintentionally or inadvertently introduce any security gaps in our own host computer. Let me actually remove the one here, and let's get the latest one from Kali. In the previous directory, we just compiled our simple hello world example, so let's copy that, move that into this virtual machine, and let's get back to our command line, where now we can run our cough loader executable, and it'll take arguments with the go function being ran, and then the path to the object file. So we want to simply run our cough loader, and let's use our 64-bit version here with go for that compiled example.o object file, and simply running this will tell us hello world. Nothing fancy, but the bare bone basics as an intro to beacon object files. Now we can take this further and implement something a bit more useful for our implant, for our agent, for our beacon, and the command and control server that we might use. With that said, speaking of command and control servers and post-exploitation frameworks and agents, please let me take just a quick moment to tell you about the sponsor of today's video, BC Security. You can maximize value across tons of different cybersecurity services brought to you by experts that have proven their skills with their tool development and community contributions. BC Security is a well-known name in our industry. If you've ever used Empire, the post-exploitation and adversary emulation framework for red teams and penetration testers, or Starkiller, the flexible user interface to command and control your Empire agents, you've already used their tools. But BC Security offers so much more. Network testing, IoT and mobile app security, endpoint security, and more. But their bread and butter is expert-led training. You can find them at Black Hat USA, one of the largest security conferences, or anytime online and on demand, with courses on advanced threat emulation between Active Directory environments, antivirus evasion, and even advanced persistent threat tactics and advanced exploitation. Don't just take a class, work together with the white glove treatment, part of their custom tailored cybersecurity services. Ask for anything and work with the proven team and expertise at BC Security. Reach out with my link below in the video description, jh.live/BC Security. Huge thanks to BC Security for sponsoring this video. All right, let's keep improving our beacon object file. Now remember, we want to do any sort of post-exploitation capability. So we really want to be able to call Win32 API functions. But BOFs are not fully linked executables. They don't contain an import table. If we want to be able to import and use these Windows API functions, BOFs need to use what's called dynamic function resolution. This is how they're able to call system library functions. Dynamic function resolution, or DFR, works by prefixing the imported symbol with the library name that it's imported from. It separates these names with a $, and you can see that to say, look, maybe you're used to calling something from the kernel 32 DLL or any other, and then the function name, just separated by that $. So let's use another primitive example for our own learning and understanding. Let's try to call the Win32 API function function getCurrentProcessID. We can see on the Microsoft documentation, thankfully, it doesn't really need any arguments or parameters to pass in, but this should come from the kernel32.dll, or that library that we'll pull from. It ultimately returns a D word to actually give us the process ID of that running process, but we can try and set this up with our own beacon object file. So let me get back to Kali Linux, and I'll get back to our source code for our beacon object file. And we know that we want to end up working with what would be in the kernel32 library, separated with the $sign, and then the function name getCurrentProcessID. We need to be able to declare the fact that we want to use this, so let's make that, well, what would be a function primitive, and specify it takes a D word as the return argument. But the special syntax, the extra little sauce you need here, is the keyword decl or declare spec_import. And that will tell your beacon object file we want to use that function. It indicates that function's imported from a DLL. And since we're including the name here, it can figure this out. So with that line added in, just that import now available to us, inside of our go function, we can just call that. Let's say we'll define a new type for a new variable, dword and the process ID, working with set as the value to our kernel32 $getCurrentProcessID. And of course, close out the function call. It takes no arguments. Now, because we already have a beacon printf function, we can just simply display currentProcessID, and we'll use a special format specifier LU and add in the other argument to display here, which is simply the PID. And that's it. That is our first real, so to speak, beacon object file. Don't forget, we do need to compile this into its own COF, or common object file. And we could run this in our COF loader just like we did with the Hello World example, but I think it'd be more fun to really use an actual command and control framework. And I know not everyone has Cobalt Strike, and maybe the price tag could be a little bit out of range, so let's try to use one of those other freely available open source command and control frameworks like Empire. Empire can load beacon object files and work with them with their implants super easily. If you don't have PowerShell Empire installed on Kali Linux, you can run sudo apt install PowerShell-Empire, but it should already be available in the latest version of Kali. So run PowerShell Empire, and if you don't provide any sort of extra arguments or parameters, it'll ask, hey, what do you really want to do after you enter your root password? Well, to start, let's use the setup command just to make sure everything is nice and ready for us. Now, before we spin up the Empire server, let me tell you how Empire allows adding various types of modules, and buffs are one of them. Modules in Empire are really made up of two different components. There's the YAML configuration in one location on the file system, and then the data that it works with in another directory. You can see some examples for the basic structure of these YAML configuration files, and you can even drill down in the documentation. Again, I'll include a link in the video description to see things specific to beacon object file modules. One thing that's especially pertinent is that it includes a format string field, and the format string is really used to pass data back and forth between the beacon object file itself and then what Empire might work with later on. To be honest, we don't quite need the format string for this simple example, but I wanted to show you this documentation so you know the differences between any other PowerShell module that might be added to Empire and what's specific to beacon object file modules. Anyway, let's get started putting together the YAML configuration. And I'll use this basic structure that they offer as an example, just kind of as a template for us to work in. Back inside of Kali Linux, the Empire module directories are in user, share, PowerShell Empire, Empire, server, modules. And if we look in here, you can see a lot of the other examples and specific subdirectories for beacon object files. So let's move into there. Oh, no S, BOF. And you can see a lot of the buffs that it already has support for. We'll talk a little bit more about some of these later, but we should create our own. So let's open up in our text editor just a simple get PID as kind of the name of our get process ID module and beacon object file. So let's create that YAML file. I'll paste in that YAML configuration that we saw from the documentation. And we will need to change a little bit here because we want a BOF module, not a PowerShell module. So I can enter my name and handle, make a little description, custom BOF to get the current process ID. We don't need any MITRE attack techniques to be present there, so we'll make that an empty list. Background can actually be false. Our output extension really doesn't matter because this is going to be a BOF, so let's make that an empty string. Does not need admin. It is OPSEC safe. The language, however, needs to be BOF and not PowerShell. Doesn't need a specific language version because of that. No specific comments, but we should add some options so we could configure or choose in the Starkiller interface for Empire what we really want to run here. Back in the BOF modules page, you can see they didn't give us the full YAML configuration, but they did give us some of the options that we could still work with and fill out for how we will run our BOF payload. So let me copy and paste to clobber the previous option section with this new one, and the architecture makes sense for us to be able to choose, because we could have a 32-bit or 64-bit beacon object file. We don't, however, need the file path being an argument that could be passed in, because that's not what our BOF needs to handle. We also don't need a format string again, so that can be an empty string. Our entry point, as you know, is the go function that we've defined, and, well, we haven't quite built out an x86 beacon object file for us. So let's make that an empty string, but then we need to specify the actual path for our .o beacon object file. Rather than the situational awareness subdirectory, let's create one specific to us. Let's create a get.pid beacon object file on our file system and the object file itself that we'll compile and put in that location. Just to be sure, though, this is a relative path. This is out of the user share PowerShell Empire blah 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 data module source bof/getpid/getpid.x64.o. Does that make sense? We'll see it when we put all the files there. Now, when we try to save this, you do need to make sure that you have root privileges because, hey, Empire is probably most likely going to be ran as root with all the power that you've got on the Linux system. So while we have now saved this file and we have our getpid.yaml, the module is added, but we need to actually put the code there. So let's move out of this directory and move into even further in our server code. In the files and folders here, let's move into the data directory and the module source directory that is ready there. Inside of that, of course, we're going to be specific to our beacon object files. So let's move into BOF. Let's create one specific to our getpid beacon object file. And you will need those root privileges, unless you just run as root in your terminal, whatever, YOLO. But let's hop into that directory, and now let's actually copy in the BOF that we compiled and called example.o, the object file, but now we can call it getpid.x64.o in this directory. Now we should have our module all set. So let's try to run sudo PowerShell Empire and spin up the server. I'll hit enter on this. It will do whatever it needs to do to be able to get everything initialized. And then it'll tell me, okay, we're running with the interface Starkiller on port 1337 or LEET on localhost here. So let's open that. We can simply access that in our web browser. I'll use Firefox. Let's paste in that address to Starkiller, and here we are. Now we can log in and interact with Empire. The default credentials here are Empire admin and password 123. So I can click submit, and now we can work with RC2 and get our beacon object file running. So in order to run the BOF, we still need an agent. We need an implant. We need the beacon running on a host, which means we need to set up a listener. Let me click to the Listeners tab and then try to create a new one. This is so our Windows endpoint, agent, implant, beacon, whatever you want to call it, is able to communicate with the command and control. We'll just use the default HTTP type. It'll call back to our Kali Linux local IP address. You can choose whatever port you might like, but since this is just for our testing, I'll use 8080. And the rest of the options are honestly fine. Let's just go ahead and click submit in the top right and then create our HTTP listener. Now let's create an actual stager. We need to be able to get this on our victim. The Windows host that say we compromised, we phished, we gained initial access one way or another. Now let's get something to stage RC2. So you can make a ton of different kinds of these, but we'll use the C# version of the Empire agent that they call like Sharpire. So we want Windows and that C# exe option here. Click into this. We can name it whatever we want. We can call it implant. The listener that we'll use should be just the HTTP option that we've created already. C# can remain as the language that will run, but the .NET version, I actually want to toggle this to .NET 4.5. Just on background, .NET Framework 4.5 was first released in 2012, and it has been included in Windows since Windows 8 and Windows Server 2012. Using the previous .NET version, like 4.0, shouldn't be necessary unless the agent needs to run on any older version of Windows. Since I'm using Windows 11, this should be fine. And we can keep the name sharpire.exe. Whether or not you want this agent to be staged or stageless is another option you can toggle here. That controls whether or not the output executable should contain everything to be able to make this callback like a fully staged agent, or it should be some stager code to be able to pull down and grab the rest of the information and config that it needs. We're fine with the rest of the options as they are. Let's just click submit and create this stager. Once that's done, now we should be able to download this. And we'll have our executable file that we could some way, somehow, bear with me, get onto our Windows target and victim. So nothing fancy here. I moved my attacker Kali Linux machine to the left-hand side and the Windows victim on the right-hand side. Let me go take a look at the Agents tab within Starkiller. Obviously, we don't have any callbacks right now. But let me go ahead and paste in our sharpire.exe agent, the implanter beacon we run, and whatever other way. If I double click on this to run and invoke it, you should be able to see on the left-hand side, it'll get a callback. There we go. Came through. And let me full screen this so you can see all the details. Here is our callback, our agent, and our implant here. Now I can interact with this if I just click on the name. We can run commands, we can even open up a live terminal, we could do whatever we might like, but we want to run a module and specifically our beacon object file, right? You can even see some of the other modules that are added if you go to the modules tab here, and there is our get PID. Of course, there are plenty that are already included, but take a look at this get PID entry. It's our custom BOF. So let me get back to the agents, interact with this, and fire it up. Nothing fancy. Let me just go use our BOF get PID. Scrolling down, we can see the option here. As we defined in our YAML file, we could choose the architecture between x64 or x86. Bear in mind, we didn't compile one for x86, so let's just use our x64. Let's click submit to run this, and let me cross my fingers here. Ooh. Module execution was queued. Our C2 sent that to the agent. I'm waiting, and I'm going to keep an eye on the notifications in the top right because I want to be able to get those results back and see them in tasks. Let's click into it and see. Ooh, it got it. Okay, we got a result. We ran our BOF get PID, and it returned the current process ID 12940. Okay, nothing fancy. Obviously, we literally just ran a single Win32 API function that took no arguments, whatever. But that's a beacon object file in Empire. And if I were to go take a look at our Windows host, remember we were doing all this just so we wouldn't have to be able to fork and run or spawn another child process or add other capability or functionality to the agent implant itself, but just extend and add on native code that can run in memory and at runtime. So if I go look at the details here, let me go find our sharpire.exe. What's that process ID? 12940. That's easily extensible custom code that we can run at any point, all within the implant itself. Kind of cool. While this was just a simple example of developing a BOF, loading it into Empire, and then executing it, there are tons of other public BOFs out and available. And these might have some more advanced capabilities. One of the very well-known and popular repositories for these beacon object files is again from TrustedSec with their situational awareness BOFs. The README page contains a bit of a list of all the BOFs that are available and a little bit more info and notes on what they are, what they do, how to use them. Really recommend you take a look through these. Again, link in the video description. But ultimately, the SA folder, situational awareness, is what will include all of the .o object files and beacon object files for us to use. If you actually go back to the root, the SRC or source directory includes all of their source code, again, for SA, situational awareness, and these can be super OPSEC friendly. Let's take a look at one just as an example, env to explore environment variables. Let's take a look at the .c source code and take a look. You can see the exact same sort of convention referencing different Win32 API function calls with that DFR dynamic function resolution library $ function name. I really recommend you scroll through these. I think these can be awesome, great inspiration and get an idea as to how you can keep making more beacon object files. This is a solid reference to be able to develop more complex beacon object files. But to be clear, back over on Kali Linux and Empire RC2, a lot of the situational awareness beacon object files are actually already included as part of Empire. Like you saw that folder when we were exploring the modules directories, this has a lot of those. All right, sorry, long video. Let me try to wrap up. Where do these beacon object files fit in? Well, there are a lot of different ways that red teamers can load and execute custom code in memory during runtime. Usually you do this with shellcode, or you load another DLL, dynamic link library, or you host the .NET CLR, like that common language runtime, to try and execute other .NET assemblies or managed code. Now, all these other options have their own pros and cons. Shellcode can be tough to write and debug, which makes a whole lot more development time and effort. And DLLs, or dynamic linked libraries, mean a whole lot more overhead because it's a fully linked portable executable. That's got an import and export table, C runtime initialization routines. It's just big and beefy. .NET assemblies mean that you're taking the entire common language runtime, or CLR, with you in order to execute the .NET assembly. Maybe all you want to do is run those Windows API functions. If that's it, well, beacon object files, or BOFs, are much easier to develop compared to writing shellcode for sure. Loading a full DLL or .NET assembly only to execute a couple of Win32 API functions, it's probably overkill. BOFs mean you get a lighter weight system of loading and executing code in memory, and the code does not need all the complexities packaged with DLLs. Even our simple get PID BOF, to get the current process ID, that was realistically like, what, 5-6 lines of code without whitespace? And if we spin down our PowerShell server, we could actually see it is just like under 1 kilobyte. And then this custom BOF can be transferred to other command and control frameworks, anything that supports running BOFs, and it makes them platform agnostic. And hey, it was super cool to be able to see them all in action within Empire. Hey, that's one of those free, open source, available, and easily extensible. You can customize, you get to interact with that C2 framework or post-exploitation toolkit. Big thanks to BC Security. Thanks so much for sponsoring this video, but thank you for having such a cool approach to everything that you're up to in the community and the industry. I hope you check them out. Link below in the video description. Hope you got to learn a lot. I hope you enjoyed this video. I hope you use BOFs. BOFs and COFs. I still keep laughing about that. All right, see you later.